Today, we are going to look at algebraic solution to a pair of linear equations. Let us look at a pair of linear equations, x minus y equals 1 and 3x plus 4y equals 10. In the previous classes, we have looked at graphical solutions. Let us try to find out how to solve this pair of equations algebraically. So we could rearrange the first equation to write x equals 1 plus y. Now let us write the second equation and substitute this value of x in the second equation and solve for y. We would get y equals 1. Now that we have the value of y, we can easily find the value of x by substituting this value of y in the first equation. And we get x equals 2. Now this method, where we are finding one variable in terms of the other variable and substituting for it in the second equation, we call this substitution method. Let us recall, using the first equation, we found x in terms of y, and in the second equation, we replaced x in terms of y. Let us see if there is another way to solve this pair of equations. Once again, let us write our pair of equations. Now this time, let us look at the coefficients of these variables. Now note that the coefficient for y is 4 in the second equation. Let us multiply the first equation with 4. We get 4x minus 4y equals 4 and 3x plus 4y equals 10. If we added these two, we would easily eliminate the variable y. Let us do that. Upon simplifying, we would find x equals 2. Now we could substitute this value of x in the first equation to find that y equals 1. Now this method is known as elimination method. We manipulated the coefficients of one of the variables and then added the equations here to eliminate one of the variables. Let us see if there is another way to solve this pair of equations. Let us write our equations once again. Now this time we are going to do something interesting. Let us look at the coefficient of y variable. So we are going to multiply the first equation with the coefficient of y variable in the second equation. Similarly, we are going to multiply the second equation with the coefficient of y variable in the first equation. Now this time we are not going to solve for x and y, so we'll keep the values as such. Now let us subtract one of the equations from the other. We see that the y variable gets eliminated. Let us rearrange the terms and we get x in terms of different coefficients. Let us write the coefficients in the first equation as a1, b1 and c1 and the coefficients in the second equation as a2, b2 and c2. Look at that! We have found a formula for finding the value of x using the coefficients in the two equations. We could repeat a similar exercise for the coefficient of x. So this time, let us multiply the first equation with a2 and the second equation with a1. We would follow a similar process of elimination and find a similar formula for variable y. Now this method is known as cross multiplication method. Note that we are cross multiplying both the equations with coefficients from the other equations. Let us look at a few problems. Solve the pair of linear equations 2x plus y equals 5 and 3x plus 2y equals 8. Let us try to use the substitution method. Let us quickly recall that we found one variable in terms of the other and then substituted this value in the other equation. So let us take the first equation 2x plus y equals 5. Let us rearrange the terms to find y equals 5 minus 2x. Now let us take the second equation, 3x plus 2y equals 8, and substitute this value of y in terms of x. Let us solve for x now. We get x equals 2. Now let us put this value of x equals 2 in the first equation and we get y equals 1. So 2, 1 is the solution to the given pair of linear equations. Let us look at another problem. The sum of a two-digit number and the number obtained by reversing the digits is 66. If the digits of the number differ by 2, find the number. How many such numbers are there? Since it is a two-digit number, let us call the digits x and y. Now, how do we represent the number? Do we just write xy? Well, that would be wrong, because simply writing xy represents multiplication between x and y. Let us look at the number 56. If we were to write it as a multiplication, we would be completely changing the number. 5 times 6 would give us 30, not 56. Instead, if we wrote 56 in its expanded form, if we wrote 56 equals 50 plus 6, then that would fetch us the correct number. What exactly are we doing here? We are multiplying the individual digits by their place value. So 5 is in the tens place, so we would write 5 times 10. And 6 is in the ones place, so we would write 6 times 1. So let us represent a number in the expanded form. We would write it as 10x plus y. Now the sum of this two-digit number and the number obtained by reversing the digits. So let us reverse the digits and write it as 10y plus x. Now the sum of these two numbers is given as 66. This gives us the first equation. Now let us look at the second statement. If the digits of the number differ by 2, let us write x minus y equals 2. Why are we not writing y minus x equals 2? Well, we could write that as well. Either way is okay. Now let us simplify our equations. So now we have x plus y equals 6 and x minus y equals 2. It is very easy to eliminate the variable y here. So let us just add these two equations. Upon adding, we get 2x equals 8. We just use the elimination method. Simplifying, we get x equals 4. Now let us put this value of x in one of the equations. And we get y equals 2. Now we used x minus y equals 2. What if we had used y minus x equals 2? Well, the values for x and y would have interchanged. So there are two values possible for this number. For the values of x and y that we have solved, the number would be 42. But if we took y minus x equals 2 as the second equation, then we would get the number 24. So the possible numbers are 42 and 24. Let us look at another problem. For what values of k will the following pair of linear equations have infinitely many solutions? Now we are given two equations and we do not have to solve for x and y. But do we know any algebraic method to identify infinitely many solutions? Recall from the last class that we saw conditions on the coefficients a, b and c for infinite solutions. So let us take a1 by a2 equals b1 by b2 equals c1 by c2 and apply it here. Let us substitute the values and pick any two pairs here. So let us take k by 12 equals 3 by k and k by 12 equals k minus 3 by k. Let us cross multiply and we get two equations, k square equals 36 and 3k equals k square minus 3k. The first equation gives us k equals plus minus 6. Why is there a plus minus sign before 6? because plus 6 squared gives us 36. Similarly, minus 6 squared gives us 36 as well. So there are two values for k possible. And the second equation, upon rearranging, gives us k times 6 minus k equals 0, which means that one of the terms is equal to 0. So either the first term k is equal to 0 or the second term 6 minus k is equal to 0. So the first one gives us k equals plus 6 or minus 6, and the second one gives us k equals 0 or 6. Now the solution common to both the equations is k equals 6. So for k is equal to 6, the pair of linear equations has infinitely many solutions.